Hello, good morning. So today our group is going to present you Hamiltonian paths and circuits and tree. So here's the member list. First one's Pariyakorn, second one Kwang, third one Pongpatui, and the fourth one Thanapon. So here's the introduction. A Hamiltonian path is the path in an undirected graph that visits its vertex exactly once. A Hamiltonian circuit is the path that begins and ends at the same vertex, and graphs possessing such a cycle are referred to as the Hamiltonian graphs. First effort in the analysis will be to discard particular properties that such a graph must possess, and our second will be to produce some special graphs that are known to be Hamiltonian. We will see that the demonstration of Hamiltonianicity relies on the general concept that the graph having enough edges must be Hamiltonian. Condition for graph to be a Hamiltonian. First condition, every pair of the vertices in the graph must be capable of being connected by the path within the graph, since the condition of being Hamiltonian requires that the path exists, by which all the vertices can be visited exactly one time. Second condition, every vertex must have degree 2 or more, since there must be a path that visits all vertices at least one time. So here's the example. In the figure 14.31, vertex A is of degree 1 with only edge AD. Connecting that vertex to the rest of the graph, it will attempt to begin our path at A. Only choice for our first stop in the circuit is vertex D. By similar reasoning, starting at any vertex other than A, we must eventually visit vertex A, meaning that the circuit must contain the sequence of vertices D, A, D, again violating the definition of being a Hamiltonian graph. Third condition that must exist within the Hamiltonian graph arises if we introduce the concept of bipartite graphs. So here's the example in figure 14.32. An undirected complete graph with more than 2 vertices is Hamiltonian due to the connectivity ensured by completeness. For an undirected loop-free graph with A vertices, if deck A plus deck B equal or more than A minus 1, for every pair of distinct vertices A and B, the graph must have the Hamiltonian path. And if the degree of each vertex in an undirected loop-free graph is at least n-1, where n is the number of vertices, then the graph has a Hamiltonian path. Sufficient condition, if the degree of each vertex in an undirected loop-free graph is at least n-1, where n is a number of vertices, then the graph has a Hamiltonian path. If an undirected loop-free graph with at least 3 vertices has deck x equal n divided by 2 for all vertices x, then it has a Hamiltonian cycle. Thank you.